In the beginning, there was only silence. Then came the ear. This is the pinna, which is the outer visible part of the ear. The shape is no accident. Catching and funneling sound into the ear. Folds of the ear modify high-frequency sound waves. Using comb filtering, give a three-dimensional picture of sound, where it travels down the auditory canal. The dimensions of this link to the 1 to 3 kHz frequency range where our ears are most sensitive. The sound vibrations then hit a thin layer of tissue called the tympanic membrane and move the tiny bones of the middle ear. The malleus, a hammer-shaped bone, the incus, an anvil shape, and the stapes, a stirrup shape, changing the pressure of sound into mechanical energy. From the chamber where these bones are housed, the eustachian tube leads to the nasal cavity and upper throat, keeping the air pressure the same as outside the body. If there was a pressure difference between the outer and middle ear, the tympanic membrane would not function correctly. Let's take a closer look at this process. The stapes has a surface area of 3.2 mm, and the tympanic membrane with a surface area of 55. All the energy from the tympanic membrane is transferred to the malleus, and being longer than the stapes, a lever action takes place. The vibrations are transferred from the stapes to the cochlea, with the pressure being around 22 times greater than at the tympanic membrane. Enough energy to move the perilymph liquid within the cochlea. An extremely effective amplification process. Uncoiling the cochlea, which is 30 mm long, spiral 2 3/4 times and cone-shaped, we see inside the basilar membrane, which lines the fluid-filled chambers within the cochlea. It is moved by vibrations from the middle ear. The tapering shape of the cochlea corresponds to every frequency we can hear and resonates from 20 Hz to 20 kHz. The movement bends tiny hairs called stereocilia, of which there are between 17,500 and 23,500, triggering a neural impulse sent to the brain via the auditory nerve, turning hydraulic energy into electrical energy. The only part not shown here are the semicircular canals, 3 fluid-filled tubes which are the body's motion sensors and responsible for balance. Goodbye.